Here we are in chapter 1. Our first learning objective for this chapter is going to be about the scientific method. Our goal is going to be to recognize the difference between observations, laws, and theories. To step back just a little bit, chemists here are going to be people who are interested in understanding how things work. People with that desire to know how the world works on that large life size scale. And the way that we do that is by understanding things down at that tiniest scale, the micro scale. Our picture on the right here depicts iron, both as a liquid and as a solid. If you want to understand the properties of iron, one way we can do that is by thinking about how the atoms of iron combine to build up that large scale structure of our metal or our liquid. As chemists, how we want to do that is by looking at our atomic structure, which in that bottom image is depicted behind me in the background here as this giant sculpture. This is actually a real life sculpture out in Belgium, where it's the atoms of iron magnified 165 billion times. That way, these atoms are large enough to be, museum exhibits, and those tubes connecting them are actually escalators. You can go up inside of those iron atoms and learn about the World Fair that this was built for. And funnily enough, across the street, where I am in this picture, is going to be miniature Europe, where actually we have very large buildings scaled down 1/14th the size to be, much smaller versions of those buildings. But here's our idea. We want to understand our real life scale objects by understanding those tiny, tiny scales, working up from atoms to infer properties about our everyday objects. How we do that is known as the scientific method. The scientific method is a way to build up our understanding, starting with observations, testing those observations, and finally coming up with good scientific laws and theories. So we want to start with some curiosity. We can observe the world and make a hypothesis. This has to be a falsifiable statement. That is, we need to be able to prove that our hypothesis was wrong. However, we're never going to be able to prove 100% that our hypothesis is correct. All we get to do is supply piles and piles and piles of evidence that do support our good hypotheses. However, anytime you have an experiment that does contradict your hypothesis, you have to go back to the drawing board and revise it or come up with a brand new hypothesis. Thus, we end up in this cycle where we can do lots and lots of experiments, trying to build up lots and lots of evidence to have well-supported hypotheses. Once this is the case, we can try to summarize our experiments into either laws or theories. Scientific laws are going to combine all of our past observations, and even better, they can predict future experiments. These laws are going to be statements saying what has happened or what will happen, and they can often be summarized using equations. Scientific theories are going to give explanations for why things are the case or how things are true. These theories are maybe harder to come up with, but they give a good understanding of what is happening and why it's happening. This is what we love. A note here, theory does not mean that it is, tentative. This is well supported by lots and lots of evidence and experiments. So this is different than a theory that a detective might have. This is a theory that is supported by tons and tons of previous experiments and data. If you're trying to differentiate between observation, laws, and theory, here are some strategies. If you have a specific measured value, a specific thing that you saw this day, well, that's probably going to be an observation. For example, if you say, I measured the pressure to be 1 atm, or this mass of a paperclip is 55 grams, that's a single measured value. Laws and theories are going to have more information. And so here's another tip. Laws can oftentimes be summarized by equations. For example, conservation of mass says that all the mass at the beginning is the same as all of the mass at the end of any process. So our equation can be the mass before is equal to the mass after. Lastly, if we're explaining why or how something works, this has to be a theory. All right, let's put this to practice. Say I measure the mass of a piece of paper before and after ripping it. All right, we measure the mass of our paper, we rip it into some pieces, and then we measure the mass of those pieces at the end. I've decided that the pieces at the end have the same mass as the original paper. Well, this looks like one specific measurement. This is something I measured once. So this has to be an observation. Second, it says matter is made out of atoms, which are not created or destroyed. They're simply rearranged during any chemical or physical process. Well, this is not one measurement. And actually, this is not really an equation. This is more of an explanation. Because of that, we can say that this is a chemical theory. Lastly, we see the total mass before a change and the total mass after a change have to be equal to each other. Well, this looks like something that could be written as an equation. In fact, this is the equation we wrote on the previous slide. So this has to be a chemical law. Lastly, here we have a practice problem. So here's one for you to try. Take a look, see if you can do it, and write down your answer. All right, and there we have it. We have been able to recognize the difference between observation, laws, and theories. Well, there we go. Thanks so much for tuning in. Hope you all have a great day, and I will catch you next time.